In the late 1970s and early 1980s, American trucking was still dominated by one name: Detroit Diesel. Their two-stroke engines powered everything from highway tractors to construction equipment, and the sound of an 8V71 pulling a grade was as familiar as the sight of a long hood Peterbilt on the open road. But while Detroit ruled by tradition, something very different was happening across the Atlantic. European manufacturers were quietly building engines that didn't just match American diesels, but in many cases surpassed them in efficiency, durability, and raw pulling power. One of those engines would become one of the most formidable challengers Detroit Diesel had ever faced. That engine was Volvo's TD162. When Volvo introduced the TD162, it was not designed to impress the American market. It was built to solve European hauling problems that were often more demanding than anything seen on American highways. Heavier loads, tighter roads, higher fuel costs, and stricter regulations forced European engineers to squeeze every ounce of usable power out of every gallon of fuel. Volvo approached the problem from a completely different philosophy than Detroit Diesel. Instead of chasing sound and simplicity, they chased efficiency, cylinder pressure, and sustained torque. The TD162 was a massive 16-litre inline-six diesel that made Detroit's two-stroke engines look archaic by comparison. While Detroit relied on firing every revolution to create power, Volvo relied on displacement, boost pressure, and carefully controlled combustion. The TD162 produced more torque at lower engine speeds than most Detroit engines ever could, and it did so while burning significantly less fuel. On long European grades, the engine didn't scream. It pulled, and it pulled relentlessly. Internally, the TD162 was built to handle forces that would have destroyed lighter designs. Its block was thick, heavily ribbed, and designed to resist flex under extreme cylinder pressure. The crankshaft was enormous, supported by wide bearings that distributed load evenly across the bottom end. Pistons were cooled by oil jets, allowing the engine to handle high combustion temperatures without cracking or scuffing. Every component was designed around the idea that the engine would spend its life under heavy, continuous load, not short bursts of acceleration. One of the most important differences between the TD162 and Detroit's engines was how they made their power. Detroit diesels relied on two-stroke scavenging and mechanical blowers to keep air moving through the engine. That gave them high power density, but it also created enormous heat, noise, and fuel consumption. Volvo took the opposite approach. The TD162 used turbocharging and aftercooling to pack dense, cool air into the cylinders. This allowed the engine to run higher compression and higher boost without destroying itself. The result was torque that came in early and stayed flat across the operating range. European truckers immediately noticed the difference. Where Detroit engines needed to be revved to stay in their power band, the TD162 could lug down and keep pulling. Long hauls through mountainous terrain became easier, and fuel stops became less frequent. The engine wasn't just more powerful, it was more usable. That usability is what gave it a reputation far beyond its original market. As Volvo trucks began appearing in international hauling operations, American fleets started paying attention. They saw engines that could move more weight while burning less fuel, and they saw drivers who were no longer fighting their trucks on long grades. Compared to the screaming two-stroke Detroits, the TD162 felt almost calm. But that calm was deceptive. Under the hood was one of the most brutally capable diesel engines of its era. Detroit Diesel was not blind to this shift. By the early 1980s, it was clear that four-stroke turbocharged engines were the future. Cummins was already gaining ground in the American market, and Volvo was proving that European engineering could compete at the highest level. Detroit's two-stroke designs were beginning to look like relics of a different era. They were loud, thirsty, and increasingly difficult to adapt to tightening emissions regulations. The TD162 didn't just outperform Detroit Diesel in raw numbers. it exposed the limitations of the two-stroke philosophy. While Detroit engines required constant maintenance of blowers, injectors, and exhaust systems, Volvo's four-stroke design ran cleaner, cooler, and more predictably. Operators who switched to Volvo Power found that their trucks spent more time on the road and less time in the shop. The shift was subtle at first, but it was irreversible. Once fleets experienced what a high-boost, turbocharged four-stroke diesel could do, the appeal of two-stroke engines faded. Detroit Diesel still had a loyal following, but the market was moving on. The TD162 was one of the engines that helped push it forward. And yet, for all its power and sophistication, the TD162 was not a fragile machine. Like the best European diesels, it was designed to run for hundreds of thousands of miles without internal repair. Oil control was excellent. Bearing wear was minimal. Turbochargers were sized conservatively to avoid overstress. When these engines failed, it was usually because the truck around them had worn out first. By the time Volvo's influence spread more widely into the global trucking market, Detroit Diesel's dominance was already slipping. The industry was demanding quieter, cleaner, more efficient engines. The TD162 delivered all three, while also offering the kind of brute force that American truckers respected. In many ways, it was not just an engine, it was a warning. It showed what was possible when diesel design focused on thermodynamics, airflow, and long-term durability, rather than mechanical shortcuts. Detroit Diesel would eventually adapt with four-stroke engines of its own, but by then, the damage had been done. The age of the two-stroke was ending. And at the center of that change stood Volvo's TD162, an engine that proved power did not have to come with noise, and that efficiency did not have to mean weakness. As Volvo trucks began appearing in North America during the 1980s, the TD162 finally had the opportunity to prove itself against Detroit Diesel on American highways. Long-haul fleets and owner-operators who were used to the constant roar and fuel consumption of two-stroke engines were suddenly introduced to something very different. The Volvo-powered trucks pulled heavier loads with less drama. They climbed grades without downshifting as often. They burned less fuel doing it. For drivers who lived behind the wheel, the difference was immediately obvious. Where a Detroit 8V71 or 8V92 demanded high engine speed to stay in its power band, the TD162 delivered its torque low and steadily. This meant fewer shifts, less stress on driveline components, and a calmer driving experience. On long western grades, Volvo trucks would simply settle into a gear and keep moving, while Detroit-powered trucks were forced to wind up and fight their way to the summit. The TD162 did not need to scream to make power. It just produced it. Fleets also noticed the maintenance difference. Detroit diesels were famous for leaking oil, requiring frequent injector service, and consuming fuel at a rate that made operating costs unpredictable. The TD162, by comparison, was tight, clean, and far more efficient. Oil consumption was low, cooling systems stayed under control, turbochargers were robust and rarely failed when properly maintained. The engine did not punish neglect, but it rewarded proper care with exceptional service life. One of the TD162's greatest strengths was its ability to run at sustained high load without degrading. European highways had already proven that the engine could handle continuous heavy hauling for thousands of hours, and American interstate trucking only confirmed it. The block resisted flex. The crankshaft held its alignment. Bearings showed minimal wear, even after extreme use. These engines were built to pull, and they did so without sacrificing their own longevity. As emissions regulations tightened, the TD162 also had a clear advantage. Its four-stroke design and controlled combustion made it easier to adapt to cleaner operation than Detroit's two-strokes. While Detroit struggled to quiet its engines and reduce smoke, Volvo's platform was already moving in that direction. The TD162 ran cooler and cleaner, making compliance less painful and more predictable. Detroit Diesel would eventually answer with modern four-stroke designs like the Series 60, but the transition came too late to preserve its dominance. By the time Detroit caught up, Cummins, Caterpillar, and European manufacturers had already claimed large portions of the market. The TD162 had played its part in that shift by proving that four-stroke turbocharged engines could outperform Detroit in every category that mattered. What made the TD162 especially dangerous to Detroit Diesel was not just its power, but its efficiency. In an era of rising fuel prices, every gallon saved mattered. Fleets that switched to Volvo power saw immediate improvements in operating cost. The engine paid for itself over time through reduced fuel consumption and fewer breakdowns. That economic reality made loyalty to Detroit harder to justify. Over time, the TD162 built a quiet reputation among heavy haulers. It became known as an engine that could move extreme weight without complaint. In oversized load hauling, in mountainous terrain, and in long-distance freight, the Volvo engine earned respect through performance rather than noise. Drivers learned that if a truck had a TD162 under the hood, it would get them there. Even decades later, these engines are still running in working trucks around the world. Many have been rebuilt once or twice, but their core components remain intact. They continue to pull loads that would strain modern engines, burdened by emissions equipment and electronic controls. Like the best diesels of the past, the TD162 was built to work first and comply second. The legacy of the TD162 is not just that it was powerful, it is that it demonstrated a better way forward. It showed that torque, efficiency, and longevity could exist in the same engine. It proved that diesel power did not have to come at the expense of fuel economy or reliability. And in doing so, it helped bring an end to Detroit Diesel's long reign. The TD162 was never meant to be a revolution. It was simply a product of disciplined engineering. But sometimes, that is all it takes to change an industry.